At 3 in the morning, you open your eyes and try to turn your head. Nothing happens. You try to lift one finger. Still nothing. But your brain is awake inside a body that will not answer because the paralysis built to protect your sleep has not switched off yet. Your chest feels heavy. The room looks familiar, except a dark shape now seems to occupy the corner. You want to call out, but your jaw will not cooperate. Then, seconds later, the lock releases. Your arm jerks. The room becomes ordinary again. The intruder is gone. That experience is sleep paralysis. A systematic review published in 2011 estimated that roughly 8% of people experience it at least once, with higher rates among students and psychiatric patients. The episode feels like a malfunction. The unsettling part is that the paralysis itself is not the malfunction. Every night, your brain is supposed to do this to you. When you enter rapid eye movement sleep, your brain becomes intensely active. Your eyes dart beneath their lids, dreams gain movement, faces, rooms, and impossible physics. Yet most of the muscles that normally obey you fall silent. This is REM atonia, a temporary suppression of skeletal muscle activity. Your eyes keep moving, your diaphragm keeps breathing, but the large muscles that would let you stand, run, or throw a punch are taken mostly offline. The reason sits inside the dream. Imagine dreaming that you are sprinting from an animal. Without REM atonia, the motor commands inside that dream could spill into the bedroom. Your legs could kick, your arms could strike the wall. The body lock separates an internally generated world from the physical one around you. Researchers traced much of that lock through pathways in the brainstem and spinal cord. During REM sleep, inhibitory signals using the neurotransmitters GABA and glycine reduce the activity of motor neurons. Those neurons are the final messengers between the nervous system and skeletal muscles. Silence the messengers, and the dream can move while the body stays still. This division is so useful that its failure reveals what the system normally prevents. In REM sleep behavior disorder, normal atonia is lost. A sleeping person can shout, punch, leap, or act out a dream. The protective lock is missing, and the imaginary chase enters the real room. Sleep paralysis is the opposite timing error. Awareness returns while the lock is still engaged. But here's where it gets darker. Being unable to move is only one layer. Your brain can also place a presence in the room with you. Sleep paralysis happens at a border. Parts of the brain are processing the bedroom while features of REM dreaming remain active. The result is not a normal dream and not fully ordinary wakefulness. It is a hybrid state, and the brain hates incomplete information. It tries to explain what it can feel. You feel pressure in your chest. That pressure does not mean breathing is stopped. The diaphragm continues its automatic work. REM sleep changes breathing, and the voluntary muscles that help you take a dramatic deep breath are less available. Panic magnifies the mismatch. Your brain receives the feeling of effort without the movement you expect and turns it into weight. Someone is sitting on you, holding you down, stealing your air. You also know that you should be able to move. The command leaves your conscious mind and produces no result. That broken prediction creates another puzzle. A brain built to detect threats does not calmly label the event as a delayed sleep transition. It searches the darkness for an agent that could explain why you are trapped. In 1999, researchers James Chain, Steve Rufer, and Ian Newby Clark organized recurring sleep paralysis hallucinations into 3 clusters. One is the intruder. Footsteps, a voice, a shadow, the certainty that somebody is nearby. Another is the incubus. Chest pressure, choking, and a hostile figure on the body. The third involves unusual movement and body sensations, floating, falling, spinning, or seeing yourself from outside. Different cultures give those patterns different names. A demon sits on the chest, a witch enters the room, a ghost arrives at the bed. The costume changes, but the underlying ingredients repeat. Paralysis, fear, pressure, and a brain trying to give an invisible threat a face. And this is the part almost nobody tells you. The monster feels convincing because your perception is doing its normal job. Your brain never receives a perfect recording of reality. It builds the most useful explanation from sensation, memory, and expectation. In a dark room, half awake, unable to move, the threat explanation wins before the calm explanation has time to speak. The image can borrow from whatever your culture taught you to fear. Research comparing experiences in Denmark and Egypt found large differences in how people interpreted episodes and how intensely they feared them. The body state is shared. The story placed over it is learned. Now, the whole scene turns inside out. The thing that feels like an attacker began as protection. The locked muscles keep your dream from using the bedroom as a stage. The shadow is the brain's attempt to explain the lock. Your own safety system creates the conditions for one of the most frightening experiences a sleeping human can have. That does not make the fear fake. Your heart races, attention narrows, seconds stretch. A hallucinated presence can feel more immediate than a memory because it is being constructed on top of the room you are actually seeing. You are not imagining a distant nightmare. You are watching dream material invade your waking space. But that's not the final twist. The lock also tells us how delicately your sense of being awake is assembled. You think waking is one clean switch, asleep, then conscious. Sleep paralysis exposes a messier machine. Vision can return before movement. Awareness can return while dream imagery lingers. The feeling that your body belongs to you can wobble while the room stays visible. Waking is a sequence, and for a few seconds, the pieces can arrive in the wrong order. That is why tiny actions can matter during an episode. People report focusing on slow breathing or attempting a small movement, such as a finger or toe, while the transition completes. The episode ends because REM atonia releases, not because the figure has been defeated. Understanding the mechanism gives the frightened brain a competing explanation. This is a sleep state. The diaphragm is working. The lock will open. Recurrent episodes can be associated with disrupted sleep, sleep deprivation, and irregular schedules. When they cause major distress, a clinician can look for related sleep problems and discuss treatment. The important boundary is simple. A brief paralysis at sleep onset or awakening is a known sleep phenomenon. Persistent weakness while fully awake belongs in medical care, not in a story about dream demons. The timing also explains why the event can feel endless while lasting a short time. You wake without the ordinary stream of movement that normally confirms each passing second. There is no turning toward the clock, no reaching for a lamp, no sitting up to reset the scene. Attention collapses onto breathing, pressure, and the dark corner. Every failed command becomes a new piece of evidence that something is wrong. Fear then makes the room feel even more significant. The episode gains a beginning, an attacker, and a plot before your muscles have time to return. This is why knowledge changes the experience without changing the machinery. A person who recognizes REM atonia can label the failed movement before the threat story takes over. The bedroom is still dark. The body is still locked. Yet the brain now has two explanations competing for the same sensations. One says an intruder is holding you down. The other says the dream system released consciousness a few seconds too early. The second story gives the episode an ending you can predict. Tonight, when you fall into REM sleep, you will not notice the moment your large muscles become quiet. You will move through impossible rooms without your real legs taking a step. Most nights, awareness and movement return together, and the mechanism remains invisible. On the rare night when they do not, remember the opening scene. The dark shape did not paralyze you. Your brain had already locked the door to keep the dream inside, then woke you before it found the key. The prison and the shield were the same mechanism all along. Nothing is as ordinary as it looks. Nothing is as ordinary as it looks.